Alrighty, so hopefully you just watched the video that my friend made, and now we're going to talk about how we can actually use this on the unit circle. Use the idea that the coordinates, sorry, I'm all, maybe this is a little bit better. Use the idea that the coordinates, your x and y coordinates, are really just, well, a x coordinate is equal to cosine of whatever the angle is, and y is equal to sine of the angle. It's very, very neat, I think, and if you don't think it's neat, I don't know what to do with you. But here's what we can say. To use this, actually, we need to figure out where all the angles are on here. So there's only certain angles that we know their exact trig value. And we talked about some of them in class and in one of the previous videos, actually. So the first one, remember, is 0 degrees. We always have to agree where 0 is. So 0 degrees, remember, on our axes here, 0 degrees is pointing straight in the positive x direction. The next significant one is 30 degrees, then 45, and then 60, and 90 degrees right here. Now, if I keep going all the way around, remember, what's nice is that you really don't have to memorize them all the way around. You really just have to memorize the first quadrant here. Wait, yeah, the first quadrant, the top left, the top right one, because everything, it's kind of mirrored and then mirrored and then mirrored again. So if this angle right here, well, it goes from 60 to 90. So in a sense, you could think of it as this angle right here is 30. So 90 plus 30 more would be 60 degrees. Well, sorry, not 60, 120. 120 degrees right there. Likewise, if we keep following this around, then this would be, 155. Nope, 135, excuse me. And then 150, then 180 degrees. Keep going all the way around, we'll get 210, 225, 240, 270, right down there. That would be all, 3/4 of the way down. We keep going. Now remember, we should end up at 360. This would be 300, 315, then 330, and then back to 360. But 360 and 0 look identical, remember. And of course, you could keep going, but they're just gonna, then you're gonna go up to 390, which is just the same angle as 330. 390. Okay, but what we're also gonna want to remember is what these are in radians, because remember, our life actually gets a lot easier when we can do everything in radians. So, 0 degrees is 0 radians, and I'll do the radians in, we'll do it in blue. 0 radians, 0 degrees, same thing. Now remember, 30 degrees, well, remember my conversion factor from degrees to radians would be times 2 pi over 360 degrees. That's my conversion factor. Also, I guess suppose you could, instead of using 2 pi over 360, 1 pi over 180. Be the exact same thing. But this, let's see, 30 over 180, what's really nice is that these all kind of share factors with 180, and which you'll see in a second. So 30 over 180 pi, remember our degrees will cancel out. Let's see, that's going to be divide both top and bottom by 3, and you'll just get pi over 6. So this 30 degrees is actually pi over 6, and I'll just use that blank there as a little fraction bar. Similarly, 45 degrees is actually pi over 2. Then now, 60 degrees would be, well, it's two 30-degree angles. So if one 60 degrees is equal to 30 degrees times 2. So in radians, that'd be pi over 6 times 2, which is pi over 3. So pi over 3 here. And lastly, well, 180 degrees is 1 pi. So divide that left and right side by 2, and you'll get 90 degrees is pi over 2. Again, what's nice about this is that you don't have to memorize the radians all the way around, right? Because think about this, 120 is just 60 times 2, so pi over 3 times 2 would be 2 pi over 3. Likewise, 135 is 45, 45, and 45, so 45 times 3. That's pi over, oops, I apologize, that should be pi over 4 right there. This will be 3 pi over 4. 150, well, let's see, it'd be, what do you think? Well, you could think of it as, well, 30 degrees times 5. And so if 1 30-degree angle is pi over 6, I'll leave it as 5 pi over 6. And then down here, 180, well, that is just pi, or pi over 1. Right? If we were to continue all the way around, you should actually practice this on your own. And I'm just going to pause it, pretty it up, and then show you at the end. Alrighty, so I filled out our unit circle. On the bottom here, you can see what I got. I believe this to be correct if you want to check my work. But here's a nice thing that you can do is, what you can do is really just memorize the, I think what the fancy name for these 4 angles are. 0, 90, 180, and then 270. I think these are called the quadrantal angles. Basically, you know, the 4 multiples of 90 degrees. And the reason that these are helpful is because if you think of all the other angles as just some degree offset of that angle. So, for example, 150 degrees, well, again, you still again have to memorize. You still have to remember these ones for that little shortcut to work. But I can think of 150 degrees. Well, I don't remember 5 pi over 6. Well, that's a little tricky to remember. But I think it's fairly straightforward to remember that 180 is equal to pi. And so 50 degrees, well, that's just, if I go backwards from 180, I would have to go backwards 30 degrees. So this is 180 minus 30. If I think of it in terms of radians, I just have pi take away a pi over 6, and I'm left with 5 pi over 6. And maybe this also relies on you being able to do some nice and simple fraction arithmetic, but it's still doable. Okay, now the angles that we've written out are assuming that you're starting off at 0 and then going counterclockwise, increasing the angle. But you could just as well do it the opposite way, starting at 0 and then decreasing the angle, in which case this angle down here in green, down here, that angle could correspond to an angle of negative pi over 6, because again, you're going downward, or sorry, you're going clockwise, which is backwards from the way we've defined positive. But we're just going to assume that we're going counterclockwise in the positive direction, just for argument's sake, and to make our lives a little bit easier. Okay? So there's a unit circle. It really helps when we can kind of quickly get through these. And I know I don't really like to emphasize, like, you have to be fast at this, but as you keep doing it, it's just going to get faster. So, like, as you put in the work, you're going to kind of remember, oh, wait, 45 degrees is pi over 4. Oh, 135 degrees. Oh, I don't remember 135 degrees exactly, but I do know, hey, it's just a couple 45s stacked on top of each other. Okay? So, again, practice this. You definitely expect to see something like, here's a blank unit circle. Fill it out. Fill out the angles. Alrighty? In class, we're going to talk about how we can actually now use this to evaluate sine or cosine of these funky angles.